Okay, here we go. I think I finally got this working. Well, it's nice to, well, I don't get to see you guys, but it's nice to be back in contact. So I hope you're all staying safe and healthy out there. And let's talk about our notes 10.2. So today we're going to talk about, whoops, let's make sure I can write. Oh, and pick a color. We're going to talk about combo Q. So last week in our 10.1 notes, we looked at the energy required to change state. So something like solid to liquid or liquid to gas and vice versa, going back in between those and the heat required for those. And we had a couple different values, numerical values for those. What we want to add in today for 10.2 is looking at the energy required to change temperature. So in 10.1, there was no temperature change, just a change in state. And today for 10.2, we're looking at changing temperature. And then the reason I call it combo Q is because we're going to then combine and do a change in temperature with a change in state. All right, so for these problems, we have a couple rules we're going to go over. Our first rule is that we're going to solve each temperature change and phase change separately. So temperature change is going to be what I call Q. We had our formula, Q equals M, the mass, times C, our constant, times our change in temperature. And any phase change, we're going to use our setup from 10.1. Once we've done that, then we add up the steps. We have to remember our sig fig rules for adding. I'll do that in an example. And our units must match. So typically what you're going to see is one thing is maybe in calories or joules, and the other is in kilocalories or kilojoules, and you need to change those so that they match. So what does this look like? Let's look at a graph. On our graph, we have enthalpy change relative to the solid in kilojoules along the x-axis. So that's just energy being added. On our y-axis, we have the temperature. So if we look at something like water, and we start down at negative 100 degrees Celsius, as we add energy to that, our temperature increases. When we get to 0, we have a phase change. At this phase change, we're going to change from solid to liquid. And that has an energy requirement that we've seen before. That is 6.0095 kilojoules per mole. Then, as we keep adding energy, so once we've added enough kilojoules that every mole of solid ice has changed state to liquid ice, then our temperature starts changing again. And our temperature keeps changing until we hit, let's make it easy, 100 degrees Celsius. At 100 degrees Celsius, we have another phase change where we add 40.657 kilojoules per mole of energy to change that liquid water into gaseous water. Again, once we've added enough energy that all of the liquid water has changed to a gas, then our temperature starts increasing again. So when we look at doing these problems, we need a few different numbers. If we're doing a phase change, so that's 10.1, we're going to use those numbers that we got in those notes. When we're doing a temperature change, we need our specific heat constant. For liquid, C is equal to 1 calorie per gram Celsius. For gas, it's different. So liquid water has a different specific heat capacity. Oh, really? That was 5 minutes all. Gaseous water has a specific heat capacity of 0.481 calories per gram Celsius, and solid is 0.5 calories per gram Celsius.